Well, hello and welcome. I think we'll go ahead and get started at our second annual Industrial and Systems Engineering Town Hall meeting. You are here to learn about the department, the college, and the university. And in the next 30 or 40 minutes, I will step you through some of the latest and greatest, along with Dr. Amanda Smith, our Associate Chair for Undergraduate Affairs, and recent graduate, Dr. Hanna Barton. I'm Laura Albert, the Department Chair of Industrial and Systems Engineering. Just a little housekeeping before we get started. We definitely want to hear from you. We are going to ask that you hold your questions to the end, and you can add them to the chat actually throughout the presentation, but we won't be reading them until the end. All right, so our talk today is going to cover 5 main areas, starting with what's new on campus at the university, college, and department levels. Then we'll discuss the updates with our undergraduate program. And then we'll move into our faculty and student updates. And here's where Dr. Barton will highlight their research. And at the end, we'll discuss alumni relations and ways to stay connected. All right, so let's start with what's new on campus. It's been an exciting year for the university. The university has been growing, and it's kind of a vibrant and an exciting time with a lot of energy on campus. We welcomed a new chancellor this past year, Chancellor Jennifer Mnookin, who comes to us from UCLA, and she's been off to a great start. During the academic year, our provost, Carl Schultz, announced that he would be stepping down from the position. We will be welcoming Charles Lee Isbell Jr. as our provost later this summer, and he comes to us from Georgia Tech's School of Computing. And the provost is our chief academic officer, so this is going to be an exciting addition to the university. So it's a lot of change on top, but I think it's good change, and we're in a really good place that will set us up for success in the future. 2 years ago, the university had its largest freshman class ever. And this past fall, we eclipsed even that record and now have our actual largest freshman class. So in the last 2 years, we've seen a lot of growth in terms of our undergraduate student numbers, which is really exciting. And it's going to be a huge benefit for our future workforce and all the innovation that will happen after these students graduate. So I'm very excited about the future. The freshman class composed of 8,628 total students. This past May, we had our largest commencement ceremony ever, bringing 7,800 graduates into the world, which is also pretty exciting. So that's a very vibrant campus community for sure these days. This coming year, the university will be celebrating its 175th anniversary, and there will be a lot of festivities. It's actually going to be a year-long celebration, so there's many ways to celebrate with us. This will all be starting on July 6th, and there's a special website to find out what's going on with the celebration and ways to get involved. All right, now moving on to the College of Engineering updates. As you might have guessed, with our record-setting freshman classes at the university, we also have seen a lot of growth at the college. This past year, we had our largest freshman class by far, which was 1,440 new undergraduate College of Engineering students. That was just at the undergraduate level. We also welcomed 396 graduate students, and this is split between master's and PhD. So in total, we have about 4,900 undergraduate students, and I think 1,500 to 1,600 graduate students. So we have a really big freshman class in total right now on campus. We're sort of bursting at the seams. It's nice that there's so much demand for our degree programs. Not every university or college of engineering is really growing right now. This reflects the demand for engineering degrees, as well as the academic excellence that we try to achieve here at the university. We also had a really big class that was graduating in May. We had a delightful May graduation ceremony with 1,200 College of Engineering graduates, and that's at all levels from bachelor's to master's to PhD. The college faculty ranks continues to grow, although a little bit more slowly. We've had some retirements, and we also added 19 new faculty members this past year, including 2 in the ISyE department. So this brings us to 210 total faculty, which is a pretty large number for us. It's definitely larger than it was a decade ago. We continue to grow. We still need more faculty to teach all these new students that are entering the College of Engineering, but it's exciting to see so many new faculty join the college. We're still trying to upgrade our facilities and build a new building in the college. There have been some setbacks in that regard. Chancellor Mnookin, Dean Robertson, and other university leaders continue to advocate for a positive outcome for this important project. And I will continue to also work hard on this effort when I have any type of chance, and hopefully we'll have some positive news in the coming months. Right, moving on to the department update. The department really is focused on academic excellence, and this is reflected in the latest rankings from this past year. Our undergraduate program is ranked 8th among public universities and 12th overall. And our graduate program is ranked 6th among public universities and 10th overall. And it is really outstanding to have a graduate program in the top 10. This really reflects the world-class education that we deliver, that we're preparing students to be leaders in engineering, as well as our research mission in advancing knowledge in industrial and system engineering and making a positive impact on society. In terms of our students, we have a larger than average industrial and systems engineering student enrollment. We have 317 enrolled students in our bachelor's program. So many students discover us and transfer in during or after their first year. So we had about approximately 100 graduates this past year. We also have 3 master's programs with a total of 86 students enrolled in these programs this past year. So we have our traditional research master's program, and our 2 professional master's programs have been really popular and have been growing. So we have one in systems engineering and analytics, and a second in healthcare systems and human factors. We also have 62 students enrolled in our PhD program, which is a really healthy number when you look at the ratio of PhD students to faculty members. So overall, we have 465 total students. Our students are very active and active outside the classroom. 49 of our undergraduate students took part in our ISyE Connections mentoring program this past year, which was really nice to see. They get so much out of that program. We have at least 100 students active in student orgs, and I'll tell you a little bit more about our student orgs later. We have about 4 associated with the department, and they've been recognized with accolades for just contributing to industrial engineering, and it's really nice to see them recognized for all that they do for our students and department. It's also worth pointing out that our students are well sought after for jobs after graduation. The college has approximately 8 positions for every 1 graduate advertised in our Engineering Career Services Center, which is really great. And 97% of our students have jobs or placed after graduation. So this is something that we're really proud of. All right, in terms of our student demographics, our students skew a little bit more female than some of our other departments on the college. And this is also a little bit high compared to other industrial and systems engineering departments at 35.7% female. And we also have the race and ethnicity breakdown on this slide if you're interested. After graduation, our students are likely to stay in Wisconsin. That's the #1 destination. Other destinations are Minnesota, Illinois, and then all international locations put together. We noticed that many of our students go on to other places in the United States outside of Wisconsin, Minnesota, and Illinois. So Badger ISyEs are everywhere and doing great things with industrial engineering. It's great to have such a broad reach across the world. Our college, we really try to keep college tuition affordable. The in-state rate is fairly affordable when you look at college tuitions, but it's still a lot. And getting a college education can be a burden for many families. And as you can imagine, scholarships are a big priority for the department, and they really make a difference to the students who receive them and are sometimes the difference between a student being able to complete a degree. We are fortunate that we have so many scholarships available to our students. And this past year, we awarded $172,000 worth of scholarships to our students. And this was across 98 scholarships that went to 62 students. And many of those scholarships are at the college, our college scholarships, and then 25 of those were department scholarships. There's actually a lot of opportunities and options available for starting scholarships. And the bottom line is that they all help the students and they make a difference. We've been trying to prioritize freshman scholarships. So when students are making a decision about college and they're really thinking about affordability, this is the time where it helps to know about scholarships. And so in terms of our undergraduate scholarships, that's been one of our main areas of focus. Our alumni would also tell you that it's pretty easy to start a scholarship, which I'm relieved to learn. And many of our alumni have started scholarships. These are generally Badger engineers giving back to the next generation. And if you're interested, please drop me a line after today's town hall, and I can follow up with some information about some of the options for starting a scholarship and what they could look like. All right, I want to move on to research. So we really are proud of the world-class education we give students and preparing them to be leaders in industrial engineering. We are also equally good at doing world-class engineering research and advancing knowledge. And we have an incredibly research active faculty. If you look at industrial engineering departments, we're ranked #1 in terms of research dollars per faculty member. Which is, we have some stiff competition, so we're really proud of this number. We have $3.8 million in research expenditures. I'm very optimistic about our future as a department. We're also publishing important research in all the top journals. So our total faculty scholarly productivity index is ranked #3, according to one of the main rankings, which is Academic Analytics. So I won't have time today to talk to you about all the interesting research that we do in the department, but I want to give you a taste of what we've been working on. And I'm going to highlight some news articles that were published by the college. So if you're interested after the talk, you can explore some more. Actually, some of the questions that we received before today's town hall had to do with AI. And I will say artificial intelligence is being integrated into our courses. We have some new senior design electives discussing AI, and we're also doing research in AI and automation. One of those projects is by Jonathan Mintz, who's focusing on safe, ethical AI in complex systems. I also want to highlight some work in additive manufacturing. So one of our new faculty members, Hen-Ten Quinn, is using machine learning and additive manufacturing to improve 3D printing. And he also focuses on 3D printing in outer space. Two of our graduate students were recognized as Inform's diversity ambassadors, and they started a project that involved outreach to high school students to get them really interested in operations research. And this is a really successful project that hopefully makes a difference to the next generation. So one way that we're studying AI and automation is looking at robot-human interaction, which can be called cobots. So Professor Rob Redwin's work really focuses on how humans and robot workers could work together so that the sum is greater than its parts. We also have faculty member Raj Veeramani, who used some statistics to demonstrate that new material that could be used as helmet liner would help improve safety and potentially be life-saving. And Professor Justin Boutelier has been studying how networks of drones could help deliver defibrillators much quicker to those experiencing cardiac arrest. So this is just a small taste of some of the research that's been going on this past year. And I encourage you to check out more on the college website or our newsletter. Next, I want to hand things off to Dr. Amanda Smith to give you an update on the undergraduate program.
Yeah, thanks, Laura. Yeah, for anyone here who doesn't know who I am, Amanda Smith, I'm the department's associate chair for undergrad affairs and also a proud alumni of the department. I did all three of my degrees, BS, master's, and PhD here. And I'm happy to be involved in this town hall as an alum, as well as sharing a little bit about the exciting stuff we have going on in our undergraduate program. So we're always working on ways to improve, update, innovate in our undergraduate program. And obviously we're all industrial engineers, so we appreciate the value of continuous improvement and always asking the question of whether we're doing things because we've always done them that way, or if there's a better way that we could do things or add, innovate in new ways. So this is just really a small sample of some of the stuff that we've been working on in the last year. There's obviously a number of ongoing projects, and in the next time we do this next year, I'll probably have some exciting updates about new ways that we're innovating with data science and data analytics on campus. One of those ways is listed here as well. But this is, again, just a very small sample of some of the things that we have really been focused on in the last year. The first one being looking for new ways to help our students grow in their ability to communicate. And this is both from a very practical written communication or oral communication standpoint, but also how they communicate in teams and with each other, with project sponsors, with people who they may not get along well with, but are working together with them. And we've been looking at different ways, techniques that we can help students learn how to function effectively on teams. Diverse, inclusive teams is something that we're really passionate about here in the department. And we want to support our students as they are learning how to navigate challenging teamwork situations. And also, as I'm sure you are all well aware, communication is probably one of the most valuable skills that you can have in any industry and any job that you may end up in as an industrial engineer. Being able to solve the problems is an important skill, but obviously being able to explain those results to stakeholders and sell your solutions to people who can make decisions is absolutely as critical, if not more critical. So we've been looking for new ways to implement this sort of communication training in our courses and outside of courses as well. And one really cool thing that we've been doing is we've had a few alumni visit our senior design courses when students are giving their senior design presentations. And give feedback to those student teams on not just the content of their presentations, but also how they're presenting the results, whether it was a convincing presentation, whether it was detailed enough, it focused on the right things, and so on and so forth. And that's been really positive. We've gotten really great feedback from students and alumni who've been enjoying being part of our courses in that way. So who knows if that's something that sounds interesting to some of you, that may be an awesome opportunity for you to engage with our undergrads in future semesters. We also have a couple of new program options that we've developed in the last year. The first one here is the Honors and Research option for our undergrad students. This is a program that was created to help students who are really passionate about being engaged in undergraduate research connect with faculty in a strategic way so that they're getting a positive research experience and the faculty member has something tangible that they get out of it as well, some deliverables that the student is able to produce through this program. So this is a really small program right now. We have 3 students who are in the very first semester of it, fall 2022. We're hoping to grow a bit, but this will likely always be a relatively small program since it's mostly designed for students who plan to go on and get a PhD or do a research master's degree after graduation. So obviously it's a relatively small percentage of our students, but for those students who are really passionate about getting involved in research, it's an awesome opportunity. We match them to a faculty member who matches with their interests well. They write a senior thesis. They'll present their work in a poster session every spring semester. It's a really neat way to have a structured mechanism for students to get engaged in research at the undergraduate level. And then last but not least, we're really excited that we are launching this fall, 2023, a new certificate in engineering data analytics. So this is a really exciting certificate that we've created. If you have forgotten, if it's been a while since you were a UW-Madison student, certificate is our word for minor. So this is really just a minor in engineering data analytics. Why UW-Madison calls it certificate and not minor, I will never know, but there it is. So we have this certificate that we're starting this fall, and we're doing this in partnership with electrical and computer engineering. It's really been an awesome collaboration with that department, since they and us in the college are the two departments that are really doing a lot of data science, data analytics already in our curriculum. So we basically wanted to create this opportunity for students who are passionate about data science and data analytics to get this more hands-on, in-depth training in engineering data analytics, since a lot of these skills are, as I'm sure you are all well aware, in high demand in various industries. And it's a really great way for students to be able to say, yeah, yes, I've taken these courses. I know what I'm doing with data analytics. We're requiring them to take an ethics course as part of this. So they'll also learn some ethics and bias of algorithms and various data analytics tools, which is obviously very important as well. So we're sure that this is going to be a popular certificate launching this fall. Stay tuned for more updates on that as it rolls out. And I won't talk too much about this because you can obviously read all of the information on the slide, but another thing we did this year was our 6-year alumni survey, recent alumni survey. So some of you probably got an email about this and may have filled it out. Thank you to those of you who did that. And this is required for our accreditation. We have to do this every 6 years, talk to alumni who graduated recently, survey them about updates to the program, where they're working now, get a sense of the demographics of our alumni base, but also get some input on what could be improved in our program to help students be successful after they graduate. So you can see a rough breakdown of the various industries that our recent alumni are working in, wide variety of different places. That was really interesting to see. And then some notes on skills that the alumni said they wish they developed more in their undergraduate degree. And you'll note that a lot of these line up very nicely with the 3 initiatives we've been working on this last year: communication, problem solving, analytics, and data related topics, and more rigorous problem solving training, which we're also trying to do more of in our both the honors and research option and the engineering data analytics certificate. And then my last slide, which I will try not to spend too much time on because I know I'm already taking up more time than I said I would, is just really quickly wanted to talk about our other big initiative that we've been working on this past year. Laura talked a little bit about the increasing the size of our undergraduate body, largest freshman class ever. And we in industrial engineering want to make sure that we are staying on trend with that growth. We have been kind of stagnant in our student body. We haven't been dropping significantly, but we also haven't been growing significantly. So we really want to make sure we're keeping up with this increase in enrollment at the college level. So we're trying to be really proactive and go after students in a variety of ways to let them know about industrial engineering, because I'm sure many of you remember that when you started out as an industrial engineer, if you were anything like me, you didn't really know what it was to be an industrial engineer. Maybe still kind of hard to explain what industrial engineering is. I still struggle with it sometimes. So informing students early on so that they can make an informed decision about which major to select has been one of our main focuses. And you can see a summary of some of the things that we have been working on here. We're hoping to increase visibility with the certificate, with our new degree options. I won't talk about our progression requirements, but basically how students are admitted to a given major within the college. There have been some changes to that we hope are positive. We're trying to be really intentional about our marketing to students at all levels. Laura also talked a little bit about scholarships. We've been working that angle as well. We're doing outreach, and we even have a committee that has undergraduate students on it that is working on taking this issue on, and they've been coming up with some really cool ideas. And we're continuing to work on this. This is an ongoing issue, never ending. We want to be growing all the time. And this is just sort of a plug to all of you. We have decided that probably the #1 challenge to attracting students is that industrial engineering suffers a bit from a marketing issue. It doesn't sound very exciting when you say that you do industrial engineering, especially when everybody's excited about data science, data analytics, all these sexy new things that everybody is doing in industry these days. Industrial engineering doesn't have the same draw to a lot of younger students. So as you're talking to people in various parts of your lives, just sell industrial engineering as much as you can. We think that word of mouth is probably one of the best ways to get new students, to attract new people to this field. So this is my ask to all of you, as people talk to you about what you do, just tell them how cool industrial engineering is, and that all people who want to do data science or data analytics should seriously look at industrial engineering, because we do it. And that is one thing that we are going to continue to work on in the next year to hope to continue to grow our undergraduate program. And that is all I got. Thank you very much for your time, and happy to answer questions at the end about the undergraduate program.
Great, thank you, Amanda. Next, I want to move on to faculty and students. You heard about our faculty a little bit earlier when I talked about some of the research highlights. We have 20 faculty members, and 6 not instructional staff of various titles as well. So here's the whole group together. And I want to point out a couple of people here. We had 2 additions to the department this past year. Han-Tan Quinn, who's in the manufacturing area, and Tony McDonald, who's in human factors. We will have 1 addition in the coming months, this summer, so stay tuned for a big announcement this summer. So we're very excited. I also want to point out that Kaibo Liu was promoted to full professor, which is really fantastic. He's just a rising star in industrial engineering, and we're happy to celebrate his promotion this spring. It's not just me who thinks our faculty and students are the best. We are a very well-recognized department. This cuts across students, faculty, and student chapters here. These are just some of the ways that have been recognized as a department. And I don't want to read all of our accolades from this past year. I do, however, want to point out a few that are worth celebrating. So on this list, Professor Emerita Vicky Beer was named Outstanding Educator of the Year by the Society of Risk Analysis. This is a national award. Han-Tan Quinn also was named received a national award and was named Outstanding Young Manufacturing Engineering Award, and this is by the Society of Manufacturing Engineers. So that's really outstanding. Then 3 of our faculty received College of Engineering awards. So Doug Wigman was recognized with the College Ragnar E. Ansad Service to Society Award for his pioneering research in safety. Professor Gabriel Zayas-Caban received the College Inclusion, Equity, and Diversity in Engineering Award. And Professor Amanda Smith, who's here with us today, was recognized with the College James G. Woodburn Award for Excellence in Undergraduate Teaching. Also on this list is our 2 students, Rain Wolf and Fernando Acosta Perez, who were awarded National Science Foundation Graduate Research Fellow Awards, which is a major fellowship from the National Science Foundation. All right, so next I want to hand things off to Dr. Hanna Barton, who will tell you about their research. Hanna, why don't you take it away?
Awesome. Okay, I think I'm good to go. First of all, just lovely to be here. Thank you for the opportunity. This is my dissertation work, so I just want to warn you, there's a lot here. I only have 10 minutes to share a little bit with you, but I've included actually some of the data in a Google document. You're welcome to use this QR code, or I think Dusty will put a link in the chat. So I'll just jump right in with some context. So children with medical complexity, or CMC, rely on undertrained and undersupported caregivers for around-the-clock care. So who are CMC? These are kids with chronic conditions that impact multiple organ systems, that have many care specialists and high healthcare utilization, with functional limitations, meaning that they often rely on medical devices to replace essential body functions, with lots of care needs. For example, this is a photo of a family providing a child a routine tracheostomy change. So they're, changing the child's breathing tube in their home. And the bottom line is that caregiving is really burdensome. So families are often forced to develop strategies to overcome the challenges that they face in delivering this complex technical care that would typically be provided in a hospital in their unique home context. So, what can engineers do to help? Well, Holden and colleagues have begun to study the work that people do to take care of themselves, defining patient work as the performance of effortful work activities by patients and informal caregivers in the pursuit of health goals. So we can extend this conceptualization to caregiving to help us understand the strategies that families are developing, which gives us a unique insight into the challenges that they face. So the patient work conceptualization situates patients and caregivers as performers of care work at the center of a care work system. And this complex system is made up of interactions between work system components, right? So for example, between caregivers and the tasks they perform, the tools and technologies that they utilize within a certain organization and a certain environment. Now, using the Systems Engineering Initiative for Patient Safety model, which as a Badger engineer, everyone knows, right? The care work system is then situated within a structure process outcome framework so that we can understand how the work system actually shapes processes and outcomes. So placing people's work at the center of a care work system provides us with an opportunity to identify barriers and facilitators. So those aspects of the work system that either impede or support an individual's ability to achieve their desired outcomes. And then those identified barriers can either be eliminated or counterbalanced by facilitators to achieve desired outcomes. Thus, the adapted work systems processes and outcomes that can feed back to and reshape the system through adaptation. System adaptation, thus, is a critical pathway for system redesign. So I was curious, what are these strategies that families develop? Now, typically strategies have been conceptualized as a response to a barrier, but to explore how strategies are a mechanism of system adaptation, I chose to expand the definition of strategy to include responses to barriers and facilitators. Secondly, I wanted to understand the relationships between work system barriers, facilitators, and those family-generated strategies. So this research was done in an existing data set, which was a result of the Advancing the Home Care of Medically Complex Children Through Human Factors Engineering, or at-home study, led by Drs. Nicole Werner and Ryan Collar. We recruited 30 caregivers of CMC enrolled in the American Family Children Hospital's Pediatric Complex Care Program. And we used a contextual inquiry method where participants were asked to walk the interviewers around their home while demonstrating caregiving tasks, and then pointing out the tools and technologies that they use to provide care. So this was guided by a interview guide to ensure that we covered all of the work system components, and then we recorded and transcribed our interviews. So my study here built off preliminary analyses by exporting an initial data set of excerpts, so excerpts of those interviews that were coded both as a work system barrier and facilitator and a strategy. So the first analysis was where some folks coded for components of the SEEPS model and then classified those components as barriers or facilitators. And the second analysis was a first step in this line of research, which was where we coded for strategies with a really broad definition. So my initial data set here is the things that were both a barrier facilitator and a strategy. So what did I do? I summarized strategies from each of those excerpts. I identified categories of strategies, created a list of unique strategy, abstracted strategy types. I'll explain a little bit more on the next slide what all that means. And then to address the interactions, I identified categories of work system barriers and facilitators, and then explored the relationship between work system barriers, facilitators, and strategies. identified strategy mechanisms, and categorized strategies by mechanism. Again, tons of data that I'm not going to present here. I really invite you to go to the link I sent, and that's got the longer tables. So I have a graphic here to kind of help explain the methods I use. So after summarizing each strategy represented by the diamond, I identified categories of strategies, which actually turned out to be categories of care work. So some chunk of strategies were actually addressing a type of care work. So, there, we got a couple of categories. Within those categories of care work, I had subcategories of care work. Okay, so that makes sense. Now, the thing that was surprising was actually some of the strategies were the same, right? So multiple families used the same strategy. So what I did was I combined those. So I'll just give you a couple of examples. 10 families used video monitoring. 3 families used pre-marked containers to speed up their formula preparation. So after combining those, I had a list of unique strategies. And then to further describe the strategies, I grouped unique strategies by similarity and abstracted them into a strategy type. So that gives you a little bit of a sense of how that worked. So in total, I identified 447 strategies. 319 of those were unique. That's in table appendix D. And then I had 108 strategy types. Now, what were the care work categories? The strategies address 9 different types of care work. So the first was providing direct care. The next was ordering, organizing, and maintaining medications, medical devices, and supplies, preparing and administering medications and feedings or food, hiring, training, and supporting caregivers, coordinating care, managing information, managing the physical environment of the home, leaving the home care environment, and then planning for and responding to emergencies. Each of these categories, again, they had subcategories, which I'm not reviewing, but are in the data. And then I identified 19 types of barriers, 18 types of facilitators that were associated with these strategies. This visual plots the number of barriers and facilitators by work system elements. So you can see there's actually a bunch of work system barriers associated with tools and technology, and they're the facilitators more evenly distributed. So just some examples of the types of barriers and facilitators are for tools and technology, having too few supplies, or conversely, having redundant or extra supplies, which, as you can imagine, is a sign of resilience in the system. So finally, that brings us to the results of the strategy mechanism analysis. So this figure displays the number of strategies per strategy mechanism. So what's a strategy mechanism? It's a way of conceptualizing how the strategy works. So leveraging a facilitator was using a positive aspect of the existing work system to achieve their goals. This is kind of the more novel piece versus avoiding the barrier or directly addressing the barrier. So what we found was that some strategies had 2 mechanisms, meaning that strategies could avoid or work around a barrier by leveraging a facilitator, or they could directly address a barrier by leveraging a facilitator. But again, the really novel thing here is that actually nearly 90% of the strategies leveraged a facilitator. So strategies most often leveraged a tool and technology facilitator. So what does all this mean? First, that families are developing a lot of strategies that address many aspects of care work. And then second, that it's important to understand what families are actually trying to accomplish in using strategies. We've typically categorized strategies by the barriers that they respond to, yet understanding families' care goals may actually offer more insight as to how to support them. And then third, that work system facilitators are integrally related to strategies. So if we'd only considered barriers, we would have missed half of the strategies. And that might be because barriers aren't perceived by caregivers, or that they're actually developing strategies proactively, which is again a sign of resilience. So, what I want to leave you with here is that to support families in participating really in the process of care work system adaptation, we have to center and give credence to their own perception of their care work system, right? They're already doing really great work to make care work in their home. So our job is to develop clear understandings of how families perceive that care work system, which then we can design interventions to support their ability to adapt their care work system and meet their goals really on their own terms. So with that, I'll hand it back to you, Laura. Thank you so much for having me.
Thank you, Hannah. That was a great presentation and congratulations again on your
Thank you.
successful defense. And now I'm going to attempt to seamlessly share my slides again.
Yeah, just kick me out.
All right, so I want to, end with just a discussion about alumni engagement. And I want to start by acknowledging our Industrial Advisory Board. Our board is composed entirely of alumni, and we had 11 board members this past year. And I want to acknowledge their many efforts on behalf of the department. They really give a lot of strategic guidance on important issues for the department, have helped to update our curriculum and to help they help the department in many ways. Sandy Ringelstetter Ennis was our chair this past year and is stepping down from being chair as well as the board after a couple of terms on the board. So we really appreciate her service. And I'm excited to announce that we have 2 new members on our Industrial Advisory Board, including Michael Garrity and Nicole Rybeck, and they will start in the fall. We enjoy celebrating the accomplishments of our alumni. One way in which we do this is with the Engineers Day awards that we have. In the college, there are 2 awards. One is an early career award, and then one is a distinguished achievement award. And as a department, we recognize one alum in each category. This past year, our early career award winner was Michelle Ranavat, who's the founder and CEO of Ranavat Botanicals, a global skincare company. And our distinguished achievement award winner was Ernest Nicholas, who's the chief supply chain officer at Hewlett-Packard. It was great to invite them back to campus and hear the latest and greatest, and to really celebrate their many career successes. We also want to hear about your latest and greatest news and accomplishments. And if you want, you can reach out and share those to me personally, as well as Jane Feller, who is our communication specialist. Her contact information is at the bottom of the slide. And alumni are also often asking, how can they get involved? There are a number of ways you can get involved. The first is just staying connected with us. If you're already getting in the newsletter, that's fantastic. It comes out twice a year. We really share a lot of our news in the newsletter. We also share our news on social media, and you can see all of our handles here. You can also connect with me personally on LinkedIn, and just connect with whatever tool you feel comfortable with, and it will be great to see you there. We also have in-person events with alumni. We have a couple coming up. The first will be an ice cream social at the Terrace this August. We haven't yet selected a date. It will be a college-wide ice cream social. We'll have a big group of ISyE Badger engineers there, and I will personally be there as well. I'm not going to miss an opportunity for ice cream. And the Chancellor does have a new ice cream flavor, Manuki dough, so you can taste it there if you haven't already tried it. We also will be having a college-wide homecoming tailgate party prior to the football game against Rutgers on October 7th, and I plan to be there as well. There are a number of ways alumni can talk to students, which is such an important way to educate the next generation and really give back to the next generation of Badger engineers. Something that we've started recently that's been wildly successful is Welcome Back Badger. And we welcome back an alumni speaker to campus, usually in the spring semester when we have our intro to engineering course, which is mostly taken by freshmen. And we welcome all alumni in different disciplines and at different career stages. And it's really been great for them to share their stories with the students. Having some variety is really informative for the students. And if you're interested in supporting the department in other ways, supporting our students, research, or other department initiatives, you can reach out to me or Tom Van Wy, our development officer, and his contact information is on the slide. And with that, I'd like to bring our town hall to an end and move on to the Q&A portion. And I think it's easiest if you add the question to the chat, but if you want to raise your hand and unmute, I'm game for that as well. Thank you for your attention. And as the messages are coming in, the questions can be for anyone, myself, Dr. Amanda Smith, or Dr. Hanna Barton.
Laura, I don't know if you saw the one question in the chat from William Schmitz. He says 25 years ago, the skills to be developed in that area, what Amanda listed, were similar to what Amanda listed now. Sorry. What barriers prevent students from developing teamwork, real world problem solving, and analytics skills? Is it credit load?
I'll
Yeah,
let
I can-
Amanda Smith weigh in on that one first.
I would say this is a good question. I don't know that there's necessarily one good answer to this question. I think there's a number of different factors that contribute to this. And I suspect that the barriers are similar now to what they've always been. And there's maybe only so much we can do to overcome those barriers. Frankly, a lot of it is that students don't know when they're students how valuable it is to develop these skills. It's after they graduate and go into the workforce that they discover the value of a lot of these more what we call soft skills, professional skills, communication, teamwork, and so on. And so we have to strike a balance between forcing students to do some of this, knowing that they won't necessarily enjoy it at the time, and also giving students the opportunity to choose to participate in some of these education opportunities. So I think that's a big part of it. Credit load is definitely a factor. Students in engineering work hard, take a lot of courses. They're hard courses. They don't have a lot of flexibility in their schedule to, for example, take a course from communications department or something like that. So what they learn needs to be kind of baked into existing requirements. And there's a lot of other stuff that we have to cover in those required courses. So figuring out the appropriate ways to put this into existing curriculum is challenging, not impossible. And we've been looking for ways that we can do that more effectively, but it just is a fact that it's difficult to figure out the right spot and the right time to teach some of these skills.
Yeah, I agree with Amanda's answer. And just to add a little bit on that, I think it is really impactful when it's cross-cutting and it's baked into the courses, because then it's really relevant to the materials. I agree that the students don't always take it seriously, but they do take it more seriously when they hear from alumni how important these skills are. And so some of our alumni who are generous enough to come back and give students feedback on these topics and courses, the students work really hard when they're getting that feedback, and they take it much more seriously. So that's just something that we've learned this past year. We're also working with the college on the teamwork skills and being part of a college-wide effort to really boost the education in that space. I think that will make it much stronger.
There's a related question piggybacking on that one. Do we know what % of undergrads have internships this summer? I know that information becomes available a bit later from our engineering career services. I don't have it offhand unless Drs. Albert or Smith know more than that. It's something we can get to, but I don't have it offhand.
Yes, I don't know that exact number either, but that would be a good number to include in next year's town hall.
There are a couple more questions. There is actually one I'm going to take from the pre-question so that we don't lose sight of it that wasn't addressed yet, which is, does the current ISyE program have opportunities to focus on safety and human performance?
Yes, absolutely. And this is not an area of my expertise, so I'm going to try to speak at it. But we have some real experts in this area. Doug Wigman is an expert on safety in particular. And so students have an opportunity to learn about this through research as well as the classroom. We have a number of courses that focus on safety. And we also hired 2 new human factors faculty. One will be joining us in the upcoming fall, and then one that just joined us this past year. And so this is really going to help strengthen our safety education in our courses.
Okay, there's a couple more here in the chat, just 2 more, I think. Could you share some details on the Industrial Advisory Board? How can we get involved?
Yeah, we're always looking for alumni to get involved in the Industrial Advisory Board. It does meet in person twice a year, and usually just starts with some conversation and us getting to know each other. And definitely shoot me an email afterwards. I'd be happy to talk with you about your interests. I see the person who asked this in the chat. This is really valuable for the department. It is a bit of a time commitment. And but if it works out, we are the beneficiaries of this generosity. So we'd be happy to have a conversation offline about the specifics.
Okay, last question in the chat. I'm interested in the area of the digital transformation in manufacturing, specifically microfactories. Are there any programs, projects focused on 3D printing, tabletop laser milling, and specifically integrating them into intelligent autonomous cells?
Oh man, this is a really specific question outside of my specialty area of operations research. I'm not going to do a great job with the answering the question. I will say that these are areas that we're really interested in the department. We haven't had a lot of folks work on things like 3D printing in the past. We do with Han Tan Quinn. Students are working on some of these skills in some of our classes that now have labs in manufacturing. And I can't speak totally about the digital transformation in manufacturing, but Kaibo Liu, who was promoted this past year, is an expert on kind of analytics and manufacturing. And we now have a number of analytics-based courses that are sort of in our manufacturing area in the department that and get to pieces of this question about this digital transformation. Absolutely, this analytics in manufacturing settings really is one way that industrial engineering has really changed over the past few years. And we've really seen that change in our curriculum that is more analytics focused. And this reflects that digital transformation. So we have a number of degrees also that focus on manufacturing and where students can dig into that topic area, including our undergraduate program has a track in manufacturing, and our master's program, systems engineering and analytics, is a little bit of a Swiss Army knife of degrees, and that students really interested in that topic of analytics and manufacturing can specialize in those types of courses. There's also a manufacturing systems engineering master's degree that's kind of managed between ISyE and mechanical engineering. And I see the follow-up comment about engaging on this topic. Yes, that I would like that too. Oh, thank you, Cindy, for your comment. Well, I think at this point, I know we're getting close to the top of the hour. I think we can bring the town hall to an end. And I want to thank you all for your attention and your engagement. I really appreciate you all staying connected to the department. It's always fun to talk to our alumni and supporters, and it was great to see you all today virtually. And I want to thank Amanda Smith and Hanna Barton for their contributions to the presentation, and congratulations again to Dr. Barton.